It is given that a black body radiates heat energy at the rate of 2 into 10 raised to 5 joules per second per meter square at a temperature of 127 degrees Celsius. The temperature of black body at which rate of heat radiation is 332 into 10 raised to 5 joules per second is. So we know that the rate of emission of heat energy is E sigma A, temperature of object raised to 4. So here it is given that the value of power radiated in the first situation is 2 into 10 raised to 5, and at a temperature of and it is given that it is per 1 meter square area, and at a temperature of the value of temperature is T1 is given as the 127 degrees Celsius. So if we are adding 273, we can convert it into Kelvin scale. So we can write temperature is nothing but 400 Kelvin, and the value of temperature of black body at which the heat radiation is, let's say now it is going to emit 32 into 10 raised to 5 joules per second for 1 meter square area. So RM is to find out the value of temperature T2. So you can use that equation, that is P is directly proportional to T raised to 4. So we can write the value of T raised to 4 is directly proportional to P, or T is directly proportional to P raised to 1 by 4. So you can write the value of T2 divided by T1 is equal to nothing but P2 divided by P1 raised to 1 by 4. So the value of P2 is given as nothing but 32 into 10 raised to 5 divided by P1 is given as nothing but 2 into 10 raised to 5, the whole raised to 1 by 4. So 32 by 2 we can take it as 16, and 10 raised to 5 and 10 raised to 5 get cancelled. So 16 raised to 1 by 4 will get us nothing but 2, because 2 raised to 4 is nothing but 16. So the value of T2 divided by T1 is equal to 2. So we can find out the value of T2 will be equal to T1 into 2. The value of T1 in question is given as nothing but 400 into 2. So we can write that is equal to 800 Kelvin.